Now let's solve class example 4. For this question, we have the beam and we have the distributed load, which is like the triangular on that one, okay? So what we have here is that we have the beam and here we have the simply supported beam, okay? So this is like the simply supported type of beam. Here we have the pin support and point A, and this is point B. Here we have RAY and we have RAX, and because this is the roller type of support, we only have RB, which is in the Y direction. All the time put the positive sign before you start solving the question, and then the first step would be draw the free body diagram and support reactions. So how much would be the summation of the force in x direction? It's always equal to 0 along the beam. And what are the forces that we have in x direction? We only have RAX, which would be equal to 0. And then what about the summation of the force in y direction would be also equal to 0. And this means that RAY plus RB, RA plus RB minus this force, because this is on negative direction, would be equal to 0. And how much is the value of this force? Is the triangular, so it would be minus 6 times 10, which is the length, divided by 2, would be equal to 0. And this means that RAY plus RB minus 30 would be equal to 0. This is my first equation, and then we know that the summation of the moment at point A is also equal to 0. Therefore, this the RB, the moment would be positive. Therefore, RB times the distance, which is 10. And what about this load, the distributed load that we have? Because this is in this direction, therefore the moment would be negative. It would be clockwise. And how much the moment would be the value of the force, which is 6 times 10 divided by 2. This is just the value of the force. And where this load is going to act, it would be here. And how much is that? It would be from here to here would be 2/3 of that 10 meter that we have. So it's always like that one. If you have the triangle like that one, the force would be this much, and this one, if the total length is L, it would act on the 2/3 of this length. Therefore, it would be, the distance would be 2/3 of the 10 that we have here, and it would be equal to 0. Therefore, 10 RB minus 30 times 20 on 3 would be equal to 0. It would be 10. So 10 RB minus 200 would be equal to 0. This means that RB is equal to 20 kilonewton. And therefore, if you put it in equation 1, you're going to get that RAY would be equal to 10 kilonewton. So this was the first step of this question. Now, we don't have any concentrated load, we don't have anything, we just have the distributed load. Therefore, we only need to count the section once here. And how it's going to look, we have the RAY, which is 10. And then we have the load like this one for the x between 0 to 10 meter. And this would be the value of the x that we have. Therefore, we're gonna have the shear force here, and we are going to have the moment here. Okay, now the question is that in order to solve this part, we need to know that what is the value of the force at this point. Look, when the beam is 10 meter, the value of the force at this point is 6. Now we have the length, which is x. So how much the force would be? So 6 on 10 would be equal to F on x. Therefore, F would be equal to 6x on 10. Okay, so it would be 0.6 times x. This is the value of the force at this point, which makes sense. Now we say that again, the summation of force in y direction is equal to 0. Therefore 10 positive minus this force. How much is that? It's 0.6x times x, which would be 0.6x squared, minus v would be equal to 0. Therefore shear force would be equal to sorry, I just made a mistake here. Would be 10 minus, what's the value of the force here? It's 0.6x times x divided by 2. Yes, minus v would be equal to 0. This means that the shear force would be equal to 10 minus 0.3 x squared. This is my first equation. And then what about the moment? This means that m, what about this moment, would be negative because it's clockwise, minus 10x. And what about the moment of this one? Would be again positive. So it would be, what's the value of the force? 0.6x times x on 2. And what is the distance? As I mentioned, it's going to act like here actually. So, which is 2/3 of x from here. Therefore, it would be 1/3 of x from here. And what is the distance to this point? Would be 1/3 of x here. And if you do the calculations, you're gonna get it as m minus 10x plus this one would be 0.3 plus 0.1x power 3 would be equal to 0, and this means that m would be equal to 10x minus 0.1 x power 3. And this is my second equation. Now easy. I want to draw the shear force diagram. I only have one equation, therefore I just put the value of x equal to 0, then it would be 10. And then I put the value of x equal to 10. Therefore the shear force would be equal to 10 minus 0.3 times 100, so minus 30 would be minus 20. So would be equal to minus 20 here. And because it's power 2, it would be like this one. So it would be positive here and negative here. This is the shear force. Again, the important point is that to find where the shear force is equal to 0, because it would be the point that the bending moment would be maximum. Shear force equal to 0. This means that 10 minus 0.3x squared would be equal to 0. Therefore, x2 would be equal to 100 divided by 3. Therefore, x would be equal to 5.77 meter. From here to here would be 5.77 meter. Now I'm going to draw the bending moment diagram, which would be also very easy. Bending moment diagram. How to do that? Just use this equation. When the x is 0, you're gonna get your moment is 0. We already know that because we have the pin support here. We also have pins, we have the roller support here. Therefore, the moment would be also equal to 0 here. What's the maximum moment? When the x is equal to 5.77. So it would be here. And if you find the value of the moment x equal to 5.77, if you find the value of the moment, just putting x equal to 5.77, you're gonna get your moment equal to 38.49. So it would be 38.49. And it would be like this one. If you are not sure about it, what I recommend you to do is that easy. Just find the value of the moment for different points that we have. For example, whatever that we have. For example, put the x equal to 1, you're gonna get this point. Then put the x equal to 2, you're gonna get this, and then you can just connect the points together, and then you will be able to draw the shear force and also the bending moment diagram for this question.